Hello, the objective of this video is to learn how to convert large and small numbers into scientific notation and back to standard form. Scientific notation is a compact way of writing numbers with absolute values that are very large or very small. For example, 8.56 times 10 to the fifth. That's a very large number expressed in a very small way. Algebraically, this would be written as c times 10 to the n power, where n is an integer and 1 is less than or equal to c, which is less than 10. We'll see a little more of that as we go on here. Standard notation. Standard notation is a number written with place values corresponding to the powers of 10, aka also known as standard form, also known as decimal form. Basically, the powers of 10 is to be the thousands, hundreds, tens, ones, tenths, hundredths, the standard way, the normal way you've written numbers. First, we're asked to write these numbers in standard form. To do that, we're going to actually multiply by 10 to the fifth. Well, instead of having to multiply 10 times 10 times 10 and then multiply the result times 8.56, we can work with moving the exponent. If we have this originally as 8.56, there's times 10 to the fifth means we're going to move it 5 place values. 1, 2, 3, 4, 5 place values to the right. I'm making the number bigger as a result because I'm multiplying by 10 to the 5, which is a big number, so I'm making the number bigger. I'm moving the decimal to the right. Now you notice I went a couple of spaces here without any numbers. When there aren't any numbers, you should fill them in with zeros. So you're going to end up with 8, 5, 6, 0, 0, 0, which is 856,000. Here we would take the 5.8 and we move it 2 decimal places to the right. You would end up with 580, which is 580. It makes sense because 10 squared is 10 times 10, which is 100. If you plug in 5.8 to your calculator and multiply by 100, you're going to get 580. Here we have 10 to the 0 power, which means we're not going to move the decimal to the left or right at all. It's just going to stay right there because 10 to the 0 is 1, and 1.2 times 1 is 1.2. But this would be scientific notation because it does have 10 to an exponent. Write each number in standard form. We got some extras here. Now they've got some negative exponents. So instead of going to the right with these, I'm going to go to the left. I'm going to be making the number smaller. This negative exponent has no effect on the sign of the number. It just tells you which direction. Instead of multiplying by values of 10, we're going to be dividing by values of 10, moving it to the left, which means I'm going to go over 1, 2, 3 place values here, which means I'm going to have 2 extra zeros in there. So I'm going to have 0 at the beginning, 0, 0, 3, 5. Now, just to take a closer look at that, we started off with 3.5. We move it over 1, 2, 3 place values. We should have a leading 0. When there's a decimal point without any number in front, you should have that leading 0. So you end up with 0.0035. This one, we're going to rewrite this here first, 2.1. We're going to move the decimal 5 places. 1, 2,
Please pardon
3,
this
4,
afternoon announcement.
5.
Jazz students, you will not be performing this evening. Please go home on your regular route. There will be no jazz concert this evening. It has been canceled. So jazz band members, go ahead and head home when the bell rings. Thank you.
Now remember, you don't drop any of these numbers. You can drop zeros in another station, but you're not going to drop any of the numbers. It still stays as the 2, 1 there. The 1 doesn't disappear. And when you're doing your work like this is showing work. You should rewrite the number out separately with the final answer so that I'm not confused and thinking this person has 2 decimal points here. Because that's what I'm looking at when I see this. I see a number with 2 decimal points. That's not correct. So make sure you rewrite your answers out to the side. the key here is to be a decimal mover, not a zero counter. When you worked with this scientific notation at earlier grade levels, they were working with just whole numbers and for that first factor, so it was easy to tack on zeros, put on a bunch of zeros or count the zeros. You can't do that when you start working with a decimal. You gotta work with being a decimal mover. When the exponent is positive, you're gonna move the decimal to the right, making the number bigger. When the exponent is negative, you're gonna move it to the left, making the number smaller. So when there are no digits present, you add in zeros. Whether it be to the left or to the right, you're going to be adding in zeros there. Take a moment, pause the video, give these 4 a try. Welcome back. 1.7 to the 5th power means I'm going to be moving to, it's a positive 5 power, so I go 1, 2, 3, 4, 5 places to the right. 1, 2, 3, 4 zeros get added in there. So that's going to end up being 170,000. That's my answer on this one. Here we have 3.86 times 10 to the negative 2. Negative means I'm going to move to the left, which is going to give me 0.0386 for my answer there. Over here, I'm going to have 4.6. I'm going to move it 1, 2, 3, 4 places. Be adding in 3 zeros there, so I get 46,000. Here I have 5.8. Be moving at 3 place values because it's a negative 3, 3 place values to the left. I end up getting 2 other zeros in here, so I have 0.0058. All right, now what about the other way? What if you're going standard notation to scientific? When you're doing standard notation to scientific, you have to remember that the first factor in a scientific notation has to be greater than 1 or equal to 1 and less than 10. It has to be greater than or equal to 1 or less than 10. So step 1, reading from left to right, you put a decimal after the first non-zero digit. Count the number of place values the decimal had to move to get to that position that you just created. That count is going to be your exponent. If you move to the left, the exponent's going to be positive. If you move to the right, it's going to be negative. The opposite of what we were looking at when we went the other direction. For example, here, I'm looking at this number. I would look first to see that there's a decimal point in here. For moving from left to right, this is the first non-zero number I see. I put a decimal there. This is where the original position of the decimal is. When there's no decimal on a number, it's understood that it's going to be at the right-hand side there. How many places did it move? 1, 2, 3, 4, 5, 6. So I have 3.45 times 10 to the 6. I move to the left, so it's going to be positive. Making this number, moving to the left is going to make that positive. It starts off as a really big number, and this is a really big number, it's millions. If it starts off as a really big number, you're going to have a positive exponent. If it starts off as a really small number like this one, it's going to be a negative exponent. Again, I'm also going to be moving to the right here, which means that I'm going to be having a negative exponent. 2 ways of testing that. Going from left to right, I see 0, 0, 0, 0. This is the first number that's not a 0. That's where I'm going to want to put the decimal point. So I'm going to have 5.8. How far do I have to move to get from here to here? Is 1, 2, 3, 4. So that's times 10 to the 4. And since we are moving to the right, it's going to be negative. So my final answer on that was 5.8 times 10 to the negative 4. Here, you may think there's nothing you can do here, but you can actually move this. Going from left to right, the first place value you see that's not a 0 is going to be a 3, which means that you have 3.85. To get from here to here, you had to move 1 decimal place. So you're going to have times 10 to the 1. Now, with that particular number, it's not right. It actually makes it, you have to write a larger number to be able to write that spot there. It's not writing it more compact, but that is the scientific notation form of that number. Here, the first non-zero decimal point when going from left to right is the 9. After that, I put there, so it's 1, 2, 3, 4, 5, 6. And I am going to the left, so that's going to give me 9.15 times 10 to the negative 6. See how lots of digits here, but this is a really, really small number. It's less than 1 in value, so my exponent's going to be negative. This was a really, really large number. It's going to have a positive exponent in value. Okay, pause the video, give this a try, and we'll go over the answers. Welcome back. This one's going to be 4.35 times 10 to the 4. 1, 2, 3, 4. This one's going to be 1, 2, 3, 4 as well, but it's going to be 8.61 times 10 to the negative 4. This one we're going to go over 2 places, so we get 2 times 10 to the negative 2. We are going to the right, so it is negative. Here we're going to move over 2 place values to get the decimal point there. You end up with 4.5785 times 10 to the negative 2. Oh, sorry, positive 2. We did move to the left, so it's going to be a positive 2 there. If I can get the 2 in there. There we go. See you in class.